Hi, welcome back. In this lecture, I'm going to introduce Cython, and we're going to look at the few simple steps from going from our pure Python code to a part of the code using C and a static library. By the end of this lecture, we will be able to describe how to use Cython, the few simple steps to compile a function to a library and call this function from Python. So what is Cython? Cython is a compiler that converts type annotated Python into a compile extension module. So in this particular lecture, we are not going to do the type annotation. We are just going to describe what are the steps to compile our Python code. But in the next two lectures, we're going to look at Python annotation and type annotated Python code. We will see that later on these type annotation are very similar to annotation in C, very similar, very close to the C language type definition. We will be able to integrate this compiled code in our Python code by just importing as a regular Python module using the import. Cython was first announced in 2007, so quite some time ago, and is a fork of the Pyrex project that was announced in 2002. So it's an extension of Pyrex and extending its capabilities beyond the original aims of Pyrex. Many Python frameworks, Python code use Cython, including CPy, scikit-learn, XML, and ZeroMQ. So it's an extremely important approach when designing Python codes for high-performance code. The example that I'm going to use in this lecture to describe how to use Cython is our Julia set code that we've seen before. As we know, at this point, the main cost of the code, the main computational cost of the code, is the inner loop that calculates the output list. So just as a reminder, so there is a outer loop here going through all the points on our grid, and then we have an inner loop here that is taking one pixel and calculating the escape function. So how many iterations it reaches this threshold. When we run this on my laptop, that is an Apple M1 Maker, the code with 1000 by 1000 grid points and 300 iteration takes roughly 3.9 seconds. So you see here on this slide that I'm basically running Python juliaset.py. That is the code that we have been profiled, developed in the previous modules. We want to use Cython in this code and make it more performant. So how we do that? Well, the first things we need to realize that we will need the three files. When using our Julia set as an example, the three files will be the following. We will have a Python code that we'll call the Cython function, and that is the bulk of our Julia code from earlier on. For instance, we can call this main file all the other code that we had before, julia1.py. And this will be responsible for building the input list and call the calculation function that we will have developed in Cython. So that's it's very similar to that. There will be a few differences we're going to see in the next slides. The second function, we will need to create a second function with the .pyx extension, right? So this is some legacy from using Pyrex, right? So this we need to create an extra file with the extension .pyx, and this is the function that we are going to compile and build. In the case of Julian set code, we can create a Cython fn, that stands for function, in pyx. So this function will contain the Python function that we want to compile and make a library. And it's also the function that later on we will annotate with the types. A third file that we need to create is setup.py, a file that contains the instruction for calling the Cython and to make the extension module. setup.py will contains all the instructions to build and compile our Cython code. Let's look at in more in detail 3 different files, how they look like in the case of the Julia set code. As I said, the very first file that we need to create is julia1.py. That is going to be the code with all our main function, except the function that we want to Cythonize. In our julia1.py, we need first to import the new module. So you see here, this is our main function. We will do import Cython fn, and this is the name of the Cython function, and then call our compile function. So this is exactly like we did before, but what we're going to do here is going to have a Cython dot. So this is the same, and then the name of the function that we will define in the function to be compiled. The rest of the code will be exactly the same. The second file that we will need is to provide a file with this extension .pyx with the definition in Python of the code that then needs to be compiled. In this case, we want to compile this function called calculate z that has the creation of the output list, and then the outer loop here and the inner loop. So we want just to take this function, we copy and paste in this file cython.pyx. As I said before, in this lecture we use a pure Python version without type annotation. This is the work that we will do in the next following lecture. So nothing is basically different from what we've done before. We just copy and paste in a separate file called cythonfn.pyx, and we obtain this second file. The third file that we need to create is setup.py, and this will include the instructions on how to compile the code. Setup.py script is called to use a Cython to compile the .pyx file into a compile module. When we're going to call this python.setup.py Python code, this is going to create on Unix/Mac system a static library with the .so extension. So the compile module will be .so file. On the Windows is likely to be something like .pyd, that is DLL like a Python library. Let's look at how this setup py needs to be defined. So we need first to import, to follow this example on these two lines. So we do some import here on setup and Cythonize, and then we call this setup function with this way. The important part here is that we need to give the exact name of the function containing the function that we want to compile, and then we provide some compiler directives. In this case, we say the compiler directives we want to give is language language and then 3. This is a dictionary. So what this language language equal to 3 means? Well, what this means is that the language language is according to 3. Here we force Python to have Python 3.x support. So we are using Python 3. In order to make the library, so we have Julia1 with the main, and then we have the function that we want to compile and make available as a library. In order to make the compilation, we need to run the setup.py script. So when we run the script, we had a few flags. So we do Python setup, and then we add build_x. In this case, with the argument build_x, Cython will look for cython.pyx and build Cython function.so, and also will create a C file on the Linux Mac system. We also add here a minus minus in place, and the in place argument will tell Cython to build a compile module in the current directory rather than into a separate build directory. So when we run it, you see is Cythonizing, and then what is doing on this particular platform is calling the ccompiler clang. We need to remember that so this is compiled code. So if we are changing the Cython fn.pyx because we want to put type annotation and we want to do different things, we still need to recompile it, right? So we will need again to call the setup.py file. At this point, we created our library with the set.py, and we can run our julia1.py. So julia1.py is the main code that is going to call the Cython code that has been compiled using setup.py code. If I run this on my Mac, it will run in 2.17, approximately like that, some around this value. So just splitting up in 3 files using this machinery compiler, compiling the part of the code that has the 2 loops for going through the pixel, we saw an improvement of going from 3.9 to 2.2. So roughly half of the time of the naive first version of using Python. As you can see, this is very quick and useful improvement for very little effort. We just split it up and then we follow that workflow. So to summarize this lecture, Cython is a compiler that converts Python into a compile extension module that we can call from Python. To use Cython, we need to have 3 files. Function we want to compile in a .pyx format with just a definition of our function. We will need a setup.py file to compile this .pyx file. And finally, we will need a third file with the main Python code importing the compile library function. And this is our julia1.py that finally we're going to run. This is the last slides of this lecture, and talk to you soon.